Hello, thank you for taking the time to watch this brief video about high-accuracy simulation models for components from Featured MVPs, Modelithics vendor partners, AVX and ATC. Using these models can significantly improve electronic simulation accuracy and help increase first-pass design success. As MVPs, AVX and ATC have teamed with Modelithics to develop and promote advanced EDA tools for the benefit of designers using their components. There are currently over 70 Modelithics models available for different types of AVX components, and over 30 for various ATC components. These high-accuracy simulation models are currently available in versions for Keysight Advanced Design System, Keysight Genesis, and National Instruments AWR Design Environment. In late 2015, the capacitor, inductor, and resistor models in the CLR library will also be available for ANSYS HFSS. Why are these models so effective? The Modelithics CLR library is primarily composed of microwave global models, which means they represent a full range of part values from a vendor component family, all within a single model. This makes possible the part value scalability feature, and in turn allows for optimization or tuning based on part value. The models also offer substrate scaling, solder pad de-embedding, statistical analysis capability, and horizontal or vertical orientation selection, among other features. Another valuable feature is that every model in the library has an associated datasheet, which contains detailed information about the model development, frequency and scaling validation ranges, reference planes, and simulation to measurement comparison plots. Modelithics models also integrate well with various popular EM simulation tools through co-simulation. The upcoming new CLR library for ANSYS HFSS will streamline this precision design approach by enabling one-step electromagnetic simulation combined with the advanced parasitic models. The following is a brief look at using ATC and AVX models within a simulator. These examples are shown in ADS. However, model features work similarly across the supported software platforms. In this demo, a surface mount chip inductor from the AVX HLC02 series and available in the Modelithics CLR library is used. In the first circuit, the sim mode is set to 0, which is the default setting. This means pad effect is included in the simulation and reference planes are at the outer edges of the pads. To show the effect of parasitics, the sim mode in the second circuit is set to 1 for the same component, making the model behave as an ideal component. Note that a substrate definition needs to be included since substrate properties are taken into account in Modelithics models. Let's simulate. On these plots, the red line is the full parasitic model for the specified substrate. The blue line is the response of an ideal model. By taking into account the pad, part, and substrate parasitics, it can be seen that these factors are important to evaluate when designing high-frequency circuits. Now, the inductors have been replaced with ATC 600S capacitor models. Again, one is set to include parasitics, and the other is set as an ideal component. Here are the results. The parasitic effects are again considerable in the component response. Now let's look at a substrate scaling example. We start with the same ATC capacitor model with a substrate definition of 20 mil Rogers 4350B, plus the ideal capacitor simulation as before. Now included are two additional circuits with the same parasitic model and sim mode set to 0, simulated on two different substrates, 4 mil Rogers 4350B and 60 mil Rogers 4003C. Upon simulation, the substrate effect can be observed by plotting the response of the capacitor on different boards. The S11 graph shown clearly demonstrates the considerable effect on the capacitor behavior caused by the different substrate properties. The substrate effect shown can make a difference in whether a design meets specs or not. Being able to accurately predict the behavior of all components in the design phase can reduce iterations, time, and cost. In addition to the CLR models for AVX and ATC components, the Modelithics Library also contains AVX coupler and diplexer models in the System Level Component, or SLC, library. One example is shown here. This is an AVX DP03 type equivalent circuit model showing simulation versus measurement up to 10 GHz. Excellent agreement is seen for the various port simulations. All of the AVX coupler and diplexer models offer measurement-validated substrate scalability as well. Please contact Modelithics if you have any questions. Thank you very much for watching.